Hello, we have a question on problem number 63, section 6.2. This is not actually 63, but it's really close to it. What we're needing to do is find the inverse of the function. So this should be a fairly quick video right here. But the function is f of x equals 5x over 4x minus 1. And what you're trying to do is come up with another function that would switch all of the ordered pairs. And so it's like a three-step process, 3 or 4-step process. The first thing you change is fx to y. So what we do is change this to y. So the first step is really easy. Just change f of x to y. The second step is actually pretty easy as well. It's switching the x coordinates and the y coordinates. Where you see a y, put an x, and where you see an x, put a y. So x equals 5y over 4y minus 1. So these two steps are the easy steps, okay? Now here comes the hard part, is trying to solve for y. And trying to solve for y when there's two of them creates a lot of issues. So what you do is, first thing to do is make it more simplistic by getting rid of the fraction. So what you do is multiply 4y minus 1 to the other side. So it's x times 4y minus 1 equals to 5y. And then multiplying the x through distributed is 4xy minus x equals 5y. Now you're not going to be able to solve for y when they're on both sides of the equation. So what you're going to do is kind of play musical chairs with these two terms right here. Because the x doesn't have a y, but the 5y does, of course. So what you're going to do is switch places with this one. So you get 4xy minus 5y, subtract 5y over, equals x, because when you add the x over, it becomes positive. So then there's two y's, but at least they're on the same side. So what you need to do is turn 2 into 1. And how do you do that is just factor the y out. So take the y out, so it'll be y taken out, 4x, because 4x times y is 4xy, minus 5, because negative 5 times y is negative 5y. And now it's just a matter of isolating the y by getting rid of the group in parentheses here, the 4x minus 5. So divide by it to the other side, y equals x over 4x minus 5. And then the very last step in the process is to change y to the inverse function. So the inverse is equals to x over 4x minus 5. And technically, that's it. That's all we really have to do. Now, if you want to build confidence and make sure you didn't make any silly calculation errors, this is kind of a feel-good thing. What you do is you come up with an ordered pair that works for this one, okay? And then if you can find one that works for that one, then switch it, okay? And it should work for that one as well. So now the trick here is trying to figure out what number that would make this pretty easy to do. And one way of doing it is just plug a number in, just hopefully you don't get a fraction. And I can't think of a number offhand that would make it really easy. So what I'm going to do is I'm just going to plug 1 in. So 5 times 1 is 5 on top. And then 4 times 1 is 4. And then 4 minus 1 is 3, so it's 5/3. Which, that's never fun to do that one, because what's going to happen is now 5/3, when you put it down in here, it should give you 1. And probably the check on this one's probably more difficult than the problem itself. So if you try 5/3, you should get 1. Let's see if it does. So it's going to be 5/3 in. So 5/3 in for the x over 4 times 5/3 minus 5. And then probably the easiest way to do this is to get rid of the little fractions by multiplying top and bottom by 3, which is really 1 anyway. And then the 3's cancel, and so that's 5. And then 3 times this one, the 3's cancel on that one, so that's 20. And then 3 times a negative 5 is a negative 15. And then 20 minus 15 is 5. And of course 5 over 5 is 1. And that's exactly what you needed, because the other one was 1, 5/3. In class, I never did one with a fraction there, because I could think of a number really easy, the ones I did. But this one's got a little bit trickier to check. Now, understand, what I've done with these numbers, 1 and 5/3, is all unnecessary anyway, if you're sure that your algebra is correct. So the ordered pairs really, make your call, okay? If you're confident that this is the answer and you made no mistakes along the way, then this is really totally unnecessary anyway. But again, it's kind of like a feel-good thing. If you get this one and then it turns around and it works, this one works the other way around, you know, the confidence just goes to the roof. So, but that's it.